Okay, this is homework 4. I just wanted to point out two of the most common errors. They weren't that common, but they were the most common ones. So the first one is in homework 1. So here nature can either go to R2 with probably 2/3, or S with probably 1/3. Then 1 gets to either move W or X, or Y or Z, and then 2 gets to move either A or B. Okay, so this is all correct. 1 gets to either move W here or X here, and 1 gets to move Y or Z here. So 1 has 4 strategies. 2 only has 2 strategies, either moving A or B. Okay, and so the first thing you do is make this matrix and you find these Nash equilibria. So then you check whether they're perfect Bayesian Nash equilibria. So this is the first one, WYAA. So it goes like this. This for 1, and then 2 is A like this. So to check if it's perfect Bayesian, remember perfect Bayesian is the specification of both strategies and beliefs. So you have to also write down the beliefs, which are right here. So this is 2/3 and this is 1/3. Why is it that way? Well, from belief consistency, right? Nature moves up here with 2/3 and 1 goes W. Nature goes down here with probably 1/3 and then 1 does Y. So these probabilities are given by what nature does and what person 1 does. Okay, so these beliefs are consistent. Given this, does 2 so these beliefs consistent. How about sequential rationality? Given these beliefs, does 2 doing something which is sequentially rational? Yes. So by going A, she gets 5 times 2/3, which is 10/3, plus 0 times 1/3 is 10/3. If she went B, she would get 9/3, right? So she is sequentially rational. How about 1? If 1 were to go down here, he would get 5 instead of 9, so he doesn't want to deviate. If 1 were to go down here and play Z, he would get 7 instead of 9, so he's being sequentially rational. So this is perfect Bayesian. So yes, this is perfect Bayesian. Okay, how about here? Now, this is the one XZBB. Okay, so 1's going X here, and Z here, and then 2's going B here. Okay, so this is a Nash equilibrium. Let's check if it's perfect Bayesian. So again, perfect Bayesian means that we specify the beliefs and strategies and check sequential rationality and belief consistency. Okay, so let's see. The thing is, 1 moves down here, 1 moves down here, so what beliefs can we put in here? So look, if we put this beliefs, 2/3, 1/3, then yes, it's true that person 2, by playing B, is not being sequentially rational, right? Given these beliefs, 2 would rather play A. However, since this information set has never reached an equilibrium, then these beliefs can be anything, okay? So in other words, belief consistency has no restriction, places no restriction on beliefs here, because according to what 1 does, 1's playing here, right? So 1's actions do not pin down beliefs here at all. Okay, so these beliefs can be anything. So in particular, for example, we can make it like this. We can make 2 believe this node probability 1 and this node probability 0. If this is the case, if person 2 has these beliefs, yeah, then 2 in fact is I'm sorry, let's do it the other way around. We'll make it probably this belief and this belief. So 0 up here and 1 back here. If person 2 has these beliefs, 2 thinks he's down here, and she is in fact doing 3 better than 0. So given these beliefs, 2 is being sequentially rational. Okay, so the point is simply that since 1 is playing X down here, right, this has never reached an equilibrium. So the beliefs here are not specified by 1 strategies. So we can make them any belief we want, in particular 0, 1. And given these beliefs, then person 2 playing B is sequentially rational. So as long as I write down beliefs like 0, 1, then this whole thing is a PBNE. Okay? So in other words, this beliefs 2/3, 1/3 is not given by nature because person 1's moving X here and Z down here. In other words, 2 never gets to, since this has never reached an equilibrium, person 2's beliefs can be anything that you want. Okay? So that's the first mistake, which is relatively common. The second mistake, which is relatively common, was this one here. This is in a problem number 2. Okay, so there are 3 Nash equilibria, and so you have to check each one to check if it's perfect Bayesian. And this is one which some people had a little trouble with. This is where 1 is playing C, okay, and then 2 plays G here and E here. Okay, so we have to check now. Again, belief consistency, sequential rationality. Now, since nature's moving here, right, 1/3, 2/3, person 1's beliefs are given by this, right? That's specified. Okay, what about person 2's beliefs? Well, person 1 moves down here and one down here, so these are never reached in equilibrium, so beliefs here can be anything. Okay, so is there any belief which person 2 has which makes playing G sequentially rational? Well, yes, if person 2 places a belief 1 here and a 0 here, then person 2 believes she's up here and then 1 is better than 0. Okay, that's sequentially rational. How about here? If we put belief, I think, yeah, let's see, 1 here and 0 here, then again, I'll just write it like this. Then person 2 believes we're here, and then person 2 is choosing 3 over 0, yeah, which is rational. Okay, so now let's check if 1 is being sequentially rational. Okay, by playing C, 1 is getting what? 5 would probably 1/3, and 5 would probably 2/3, which is 5. Okay, so this is what 1 is getting in equilibrium. If 1 were to play B here, 1 would eventually get 6, right? And 4. He would get 6 would probably 1/3, and 4 would probably 2/3. And this is going to be 14/3, which is less than 5. Okay, so playing B is not going to do better than 5. How about if he plays A? If he plays A, he gets 6 with probably 1/3, plus 4 times 2/3 again, so this is also 14/3, which is less than 5. Okay, so again, if he plays A, he gets this, 6 would probably 1/3, and 4 would probably 2/3. Okay, so yeah, either way, it gets less than 5. So this is in fact sequentially rational. Person 1 playing C is sequentially rational. Okay.